Welcome back. In this section, we'll be talking about equations of circles and graphs of equations of circles. If we're defining what a circle is, it's just all the points that are a fixed distance away from the center. So here I'm using HK to refer to the coordinates for my center of my circle, and R to be the distance between the center and any point that's on the circle. We have a standard form for our equation of our circle, and this really comes back from our distance formula. If we're thinking about our distance formula, the distance was the square root of the difference between the x coordinates squared plus the difference between the y coordinates squared. And so if we're thinking about a circle, well, we say that the radius should be the distance between any point on the circle and the center. So the difference between the x coordinate on the circle and the x coordinate in the center, plus the difference between the y coordinate on the circle and the y coordinate at the center. And of course, if you square both sides of that equation, then you wind up with exactly what we have in our formula that you can see down here. That we would have that x minus h squared plus y minus k squared would be our radius squared. One form for the equation of a circle that we'll see when we get into trigonometry would be the unit circle. A unit circle, that's the special circle that is centered at the origin, centered at 0, 0. And it's called a unit circle because its radius is 1 unit. So if we're thinking about the equation of the unit circle, h is 0, k is 0, and the radius is 1. Or in other words, x squared plus y squared equals 1. That would be the equation for a unit circle. And that's something that, again, that we'll see when we get into trigonometry. That'll come up in a bunch of places. So we want to start off with this example where we're going to take a circle. It's got a center of 3, -1 and a radius of 5. We want to come up with its equation, then find all the intercepts. So for coming up with the equation, that part's the easy enough part. We have that our equation would be x minus the x coordinate for the center squared plus y minus the y coordinate for the center squared equals the radius squared. Or if we wanted to simplify it, x minus 3 squared plus y plus 1 squared equals 25. Okay, so we've got our equation, and now we can use that to find our intercepts. If we're looking for the x-intercepts, we're going to be letting y be equal to 0. So that means we would have x minus 3 squared plus 0 plus 1 squared equals to 25, which if we simplified that, that would be x minus 3 squared equals 24. What we have here is 0 plus 1 squared, that's 1 squared or 1, and when we bring it to the other side, we now have 24. Now I just use my square root property. Something squared equals 24 means that that something should be plus or minus the square root of 24. So x should be 3 plus or minus, and then of course don't forget your square root of 24 needs to be written in simplest terms. Root of 24 is square root of 4 times square root of 6. So we have two x-intercepts. We have 3 plus 2 root of 6, comma 0, and we have 3 minus 2 root of 6, comma 0. Those are our two x-intercepts. And for our y-intercept, we're going to be doing much the same thing. We're going to be letting x be equal to 0, and then we're going to solve to find what is y. Just going to need to add here an extra page. So when we've put in 0 for x, then on the left side we'd have 0 minus 3, which is negative 3, squared would be 9. And so we'd have y plus 1 squared would be 16. Again, using my square root property, y plus 1 should be plus or minus the root of 16, which is the same thing as 4. So we have two values. Y is negative 1 plus or minus 4. So that means that y is equal to negative 1 minus 4 or negative 1 plus 4. So we have two y-intercepts, 0, negative 5, and 0, 3. Now for graphing circles, if we have them in standard form, it's easy enough to graph because basically all we'll need to do is plot our center point and of course make sure it's labeled, and then you know the radius, or you will know the radius if it's written in standard form. So you would go r units up from the center, down from the center, to the right from the center, to the left from the center, to get 4 points that are on the outside of your circle. And then we would connect our points. And of course, you'd want to be labeling these points as well with their coordinates. That's of course easy enough to do because you know where the center is and you know how many units you went up, down, left, and right. So you'll be able to find the coordinates for those 4 points. And then of course, the last thing that we'll need to do after we've graphed our circle is label it with its equation. So we'll do this here. If we're thinking about this equation that we have, x plus 2 squared plus y minus 1 squared equals 9. That's the same thing really if you're thinking about it as x minus negative 2 squared plus y minus 1 squared equals 3 squared. In other words, our center should be at negative 2, 1. And that we should have a radius of 3. So I've plotted my center, negative 2, 1, and what I'm going to do is go 3 units to the right. So increasing the x-coordinate by 3, which brings me to the point 1, 1. I'll go from the center 3 units to the left, 1, 2, 3. So decreasing my x value by 3, so that's the point negative 5, 1. From the center going up 3 points, 1, 2, 3, increasing the y value by 3 to give me the point negative 2, 4. And then from the center going down by 3, 1, 2, 3, decreasing the y coordinate by 3, bringing me to the point negative 2, negative 2. And then I'll just do my best to connect these points to make a nice, smooth circle. There we go. And then the last thing I should do is make sure that my graph itself is labeled. So I'll label that here on the side. X plus 2 squared plus y minus 1 squared is equal to 9. There we go. I've got my equation of my circle. I've got my graph of that equation. I've got my points all labeled. X-axis labeled, y-axis labeled, tick marks are all labeled. And there we go. That's a nice well-labeled graph of my circle. Now, the standard form, like I said, that shows you where the center and the radius is. The general form for the equation of your circle doesn't really tell you where the center is or what the radius is. This would be something where we have x squareds and y squareds with x's and y's and some constant all on one side equal to 0. As it stands right now, there's no way to see what would be the radius, what would be the center. But to find what the radius and the center would be, we just have to take that equation and complete the square twice. Using the x squared and the x term, complete the square so that we would have x together with some number squared. Doing the same thing with the y's and y squareds, completing the square with that so that we would be able to write it as a nice perfect square, y plus some number squared. And then we'd be able to rewrite the equation so that it's x minus the x coordinate squared plus y minus the y coordinate squared equals to some number, and then from that we'd know what the radius would be. So let's start with this. I have this equation, x squared plus y squared plus 6x minus 10y minus 66 equals 0. And I want to find the center and the radius for that circle, and so the first thing that I'm going to do is move the x squareds and the x's next to each other, and I'm going to move the y squareds and the y next to each other, and the 66 I'm going to move to the other side of the equation because the constant will eventually all go to the right side. I want to be having just the r squared on the right side eventually, so I'll start by moving my constant there right now. And then the next thing that we'll need to do is start working on completing the square. I'm going to do these one at a time, not expecting you to do them one at a time, so you could complete the square for the x's and the y's all on the same line. But I'm going to go one step at a time just to remind ourselves what we're doing here, that when we're completing the square, we're looking for the extra value, that extra constant value that needs to be added in so that the x squared, the x, and the constant would turn out to be a nice perfect square. And so we do that by looking at the x term and asking ourselves for that coefficient. If we cut that in half and then square it, what would we get? So positive 6, if we cut that in half, that's positive 3. And positive 3, if we square that, we have 9. So 9 is the amount that I'm going to add to both sides of my equation. So on the left side, the x squared plus 6x plus 9, that is the same thing as the perfect square, x and half of the x coefficient, x plus 3, whole thing squared. There we go. So now I'm going to do the same thing with the y's. I'm going to complete the square for the y. So again, looking for the value that I need to add on to make what I have with the y's a nice perfect square. And to do that, I ask myself, for the coefficient for the y, that minus 10y, if I cut that minus 10 in half, that's negative 5. And if I square it, negative 5 squared is positive 25. And so positive 25, that's what needs to be added onto both sides of my equation. So that what I would have with the y's, y squared minus 10y plus 25, that would be a nice perfect square. Y half of negative 10 is negative 5, so y minus 5 all squared. And so now we're pretty clear. This is written in standard form, and so we can see that if we were looking at this, this is the equation of a circle where the center is negative 3, 5, and where the radius happens to be 10.